What's poppin', dogs? Mr. Allen here with some polynomials in this video. We got to write a polynomial function with the given zeros. And I got two different examples here. Both involve imaginary numbers. All right. So for the first one here, we have a 0 of x equals 2 plus 5i. Well, if you remember with imaginary numbers, they always come in pairs because the way I get an imaginary solution is when I'm square rooting a negative. And let's think about, like I said, the quadratic formula for a sec. I would have plus or minus the square root, right? So positive, negative, it's two different results there, right? So for this one, I've got 2 plus 5i. I'm also going to have 2 minus 5i. So that's my other 0 there that I'm going to use to write this function. Okay, so let's start writing this function out. I'm going to have f of x. I'm going to come over here. Let's see here. F of x equals, and when you're writing with polynomials, we're going to take x minus whatever that 0 is. Like, so it's easier to see with just integers. If it were this one here, it'd be x minus 3, okay? With the imaginaries, it looks kind of messy, but we're going to do x minus, I'll get a second color in here. We're going to pop our 0 in there. We're going to have 2 plus 5i, okay? And I'll do the same with my other one here for the 2 minus 5i. So I'm going to have x minus, and then we got our second set of parentheses here. Whoop. Boom. And we got 2 minus 5i. Cool. Alrighty. It's fun. I like these. The colors are popping. So next thing here is I got to distribute that negative through. And what's kind of nice is if you make a mistake here and forget about these inner set of parentheses, the algebra kind of like, it's like a double mistake works itself out. Don't do that, okay? Don't think like, I'm doing this right. Yeah, because I'm getting the right thing. You got to have the parentheses there. If they're checking your work and they don't see that, you're likely to get some points off. The algebra does work itself out or corrects itself in a way here, but it's just getting lucky. There's very few times where you can get lucky like that. So I'm going to distribute my negative. I'm going to do my math properly here, guys. I got x minus 2, right, minus 5i, close them. And then I've got x minus 2 plus 5i, close them. All right, now what you might see here is I'm going to regroup this because I see an x minus 2, and I see an x minus 2. All right, that's not changing anything into multiplication or anything like that. I'm just noticing that those two are the same, right? And what I'm getting at here is if I have something, the same thing, and I'm subtracting and adding the same thing, it's like a difference of 2 squares situation. Check it out. All right, I'm going to do a little side math here. I'll do it in blue. Actually, no, I'll do it in yellow. Okay, so if I had this, okay, way down here. If I had x minus 5 and x plus 5, when I multiply this out, I'd get x squared, I'd get positive 5x, and I'd get minus 5x, and I'd get minus 25, right? Well, my 5x and negative 5x cancel, leave me with just x squared minus 25. And what we can do is use this, right? Use what we know here to help us with this problem right here and take some of the legwork out of it, if you will, okay? So what I'm going to do is I'm going to multiply the x minus 2 and the x minus 2 together here, okay? And that's going to give me x minus 2 squared, or just x minus 2 times x minus 2. We'll leave it like that. Cool? This one here is going to be positive 5i times x minus 2. And this will be negative 5i times x minus 2, which will cancel each other out. I'm not going to worry about the outer and inner because it's the same situation as multiplying these two binomials together, which we've done a million times prior to this, okay? So then I can just focus on these two here, which is going to be negative 25i squared. There we go. All right, so I could have written all that out. It'd go really long here, but it's going to work out this way every single time. You got to notice the grouping there. I creatively grouped that to allow me to think of this as like the difference of 2 squares type of thing where the middle terms cancel out. All right, enough of that. Let's continue here. I've got, let's see here, x times x is going to be x squared, right? And then we got negative 2x and negative 2x is negative 4x plus 4. And then we have plus 25. I squared is negative 1. Times negative 25 is positive 25. So my final here, f of x equals x squared minus 4x plus 29. That is my polynomial function with the given zeros there. Wonderful. It's in standard form. That's awesome. Now, question for you. Would we have known that that was going to be a quadratic right off the bat? Once I established that we are going to have that second 0 there, 2 zeros means it's going to be quadratic. If I had 3 zeros, that's cubic. If I had 4 zeros, that's quartic, so on and so forth. So a good multiple choice question is, hey, what's the degree of this polynomial going to be if it has this as a 0? It would be quadratic, right? If they don't mention any others, okay? So what's my degree going to be for this one over here? Well, I got 1 0, 2 zeros. Wait, that's also going to have another buddy there, isn't it? It's going to be x equals -1 plus 2i, right? I'm going to have the positive, the switching of the sign of my imaginary number there. So I got 1, 2, 3. That's going to be a cubic function, right? So good thing to know, all right? Good thing to know. Let's continue, shall we? Let's do it. So I'm gonna go g of x this time, switch up my functions. All right, so the first one here, x minus 3, no big deal. Next one here, I'm gonna have x minus -1 minus 2i, and then we'll have x minus -1 plus 2i. Close, close. Beautiful. All right, same kind of algebra happening here. We just got this x minus 3 chilling out front this time. I'm going to deal with that one at the very end, okay? So wait with the x minus 3. I know you want to chill with the x minus 3. We're going to wait on that one. I'm also going to draw a little line here so I can use a little bit of that room, you know what I'm saying? All right, so equals x minus 3. We're going to distribute our negative now. So the negative goes in. I'm going to get x plus 1 plus 2i, and we have x plus 1 minus 2i. Excellent. And once again, we can see that we have this x plus 1 occurring and x plus 1 occurring. So I can use that much like we did over here and think about how we'd multiply out when we have this type of situation going on that we're used to, but now we're throwing in imaginary numbers with it. So again, get back to some familiar mathematics to help you solve a new problem. All right. So I've got x minus 3 still chilling, right? X minus 3. You good. You're good. I'm going to throw some brackets now, okay? Because we got a lot going on here. I've got x minus 1 times, or sorry, x plus 1 times x plus 1. We know that the negative 2i times x plus 1 and the positive 2i times x plus 1 are going to cancel. And then I'm left with minus 4i squared. Close the brackets, okay? You don't have to use brackets. I like to use them in this one because it starts to get a little confusing. Okay, so we got equals. X minus 3 is still chilling. I'm waiting to use that. X minus 3, we're going to use it, okay? And then over here, we've got x squared, and then it'd be 1x, and 1x is going to give me 2x plus 1, and that's going to be what, plus 4? Because I squared is -1 times -4 is positive 4. Cool. Then I'm going to clean it up. So we got x minus 3. Almost time for the x minus 3. X squared plus 2x plus 5. Now it's time to multiply by the x minus 3. And I actually like to organize it in this way if I have the space. I'm going to show you guys what I like to do. So we've got the x needs to distribute to all 3 of these, okay? And I'll do these in a couple different colors here. So we got x times x squared is x cubed. X times 2x is going to be positive 2x squared. And x times 5 is going to be positive 5x. Then, if I come around with the -3, -3x squared, I can write that, -3x squared, right below that one and just organize my like terms because it's going to work out in order since the 2 terms that we're multiplying here are in order as well, right? The x minus 3 is in descending order, x squared plus 2x plus 5, descending order. So it'll work out real nice. So -6x and then -15. There we go. And then when I put this all together, I can like add it vertically there. All right, so we get x cubed, so we're going to go g of x. This is going to be our final answer. G of x equals x cubed. Then we have minus x squared minus x minus 15. There it is. Look at that. It is a cubic function, as we thought from the beginning there. 3 terms. It's cubic. That's fantastic. There we go. We got our polynomial functions with the given zeros. Worked out all the way to here. Some teachers will allow you to leave it in this form right here, especially if we start dealing with like quartics. It's a lot to multiply out. So sometimes they'll let you leave it in factored form with real numbers only. So they don't want you to have it with the imaginary numbers in there. They make you work it out to about this point right here. So make sure you read the directions and that you're not doing too much work and getting all the way down to here if you don't have to. Because if you're on a test, time is money, baby. You got to save that time for another problem. There we go. It's awesome. I hope you guys have a fantastic day. And if you like this video, like it. Don't just like it in your head. Like it, and subscribe. See ya.